Geometry, Unit 6, which is Chapter 4 in the book, Section 4. Are there congruence shortcuts? Congruent triangles. Triangles are congruent if all of their corresponding parts are congruent. That means each side and angle is congruent. So if I have triangle ABC is congruent to triangle DEF, this means AB is congruent to DE, BC is congruent to EF, and then AC is congruent to DF. Oh, that's a typo. That should be DF. And then angle A to angle D, angle B to angle E, angle C to angle F. A to D, B to E, C to F. So if I drew those out, A, B, C, D, E, F, congruent, 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 and then the angles are congruent here as well. So triangles are congruent if every single part of both triangles are congruent to each other. Do we need to know all the sides and angles to prove congruence? Well, actually we don't. We don't need every single angle and every single side to prove triangles are congruent. Then there's a total of 5 different ways we can prove triangles are congruent. And then there's 2 ways you might think you can use, but you can't. So here are all the ways we can prove triangles are congruent. And over here, we've got ways you can't use. And then we're going to talk about why you can't use those. We're going to look at, today, side, 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 and side angle side in this set of notes. And we're also going to look at why side, side angle doesn't work. So, if we know all 3 sides of a triangle are congruent, this does mean the triangles are congruent. So if your 3 sides are congruent, triangles are congruent. So I can state here, notice we've both triangles to 3, 5, 6. I can state that triangle ABC is congruent to triangle DEF by using side, side, side. So since their sides are congruent, I can make that statement. We also can use side, angle, side. If you have 2 sides of a triangle are congruent and the included angle, that means the angle that's between the congruent sides, that means the 2 triangles are congruent. So I can do the same statement. I can say triangle ABC is congruent to triangle DEF by side, angle, side. Now, why does side, side, angle not work? So if you have 2 sides of a triangle that are congruent, but you have an angle that's not the included angle, that means the triangles can be proven because there's actually 2 possibilities. I know this is length 10, and I know these are length 8. I have 2 possible options. Because with this 40-degree angle, that could rotate, this could rotate to 2 possible intersections with that purple line. So side-side angle is not enough information to prove 2 triangles are congruent because there's 2 possibilities. Now let's look at some more complicated scenarios here. So we have 2 triangles. We've got a triangle here and a triangle here. So we do have 2 triangles. But it appears I don't have enough information. I've got two sides that are congruent. But we know BC is congruent because whenever two triangles share the same side, they both are sharing BC, and BC is congruent to itself. So I can go ahead and mark it as congruent. I now can say triangle ABC is congruent to triangle YBC by side, 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 because I showed that all three sides are congruent, so that the two triangles are congruent. Let's do that again. So again, they share a side. I can go ahead and mark this. And then look what we've got. Side, angle, side. Side, angle, side. The angle is in between the two congruent sides. Since the side's in between the two congruent sides, I can do side, angle, side. So triangle ABC is congruent to YBC by side, angle, side. We also can have scenarios where you've got some vertical angles. So on this diagram, we've got two triangles, but I've only got two sides on both those triangles. So we don't have enough information, it appears. But we actually do have enough information because we know vertical angles are congruent. So I can mark it. I now know that these triangles are congruent. Triangle ABC is congruent to triangle YXC. YXC by side, angle, side. And again, look. Side, angle, side. The angles included between the two sides. So let's do some two-column proofs. We did these earlier in the year. So we've already got the statements lined up. We just have to fill out the reasons. So we're given AB is congruent to AC, BY is congruent to CY. And we have to prove that triangle BYA is equal to triangle CYA. All right, the first statement, AB is equal to AC, BY is equal to CY, that was given to us. That was given to us. Next, line AY equals line AY. Well, that seems obvious, but this is actually a property. This is actually the reflexive property. When anything equals itself, this is the reflexive property. Now I can say triangle BYA is equal to triangle CYA because of side, side, side. Let's look at one more two-column proof. So we're trying to prove ABC is equal to YXC, and we're given AY and BX bisect each other. Okay. So since AY and BX bisect each other, I can state that AC is congruent to CY, BC is congruent to CX. Why can I say that? Well, if two lines bisect each other, that means they cut each other in half. This is the definition of bisectors. Of segment bisectors. And then we can state that angle ACB is congruent to angle XCY because they are vertical angles. And then now I can say the two triangles are congruent because we have a side, angle, side. Side, angle, side. And that is the end of this lesson.